Hello everyone, welcome to the third session of 5G non-standalone mobility. Actually, in this video, we will break down into the essential understanding of 5G non-standalone mobility, and we'll try to explore or exploring all the end-to-end call flow for related to the mobility using traces and logs. And also, we'll try to highlight the most common issues and problems you might face while doing any troubleshooting for the 5G mobility, non-standalone mobility. And also we'll try to address the most common parameters related to the tuning or for the layering of the mobility in general and the types of handovers or the mobility we have it in non-standalone. Just a quick comment or a reminder that if you remember that I would like to highlight that this actually series of financial series will try to cover all the related aspects in terms of practical or theoretical knowledge of 5G non-standalone, including features, traffic management, throughput, troubleshooting, and also frame structure and anchoring and all these kind of things. We'll try to cover it on all the series in case to have a complete, at the end you can have a complete course about 5G non-standalone, which can help you like even to move from beginner level into a very advanced level. So please make sure to subscribe to the channel and to spread the knowledge. So let's move forward. Actually, this will be the contents of the day. That first, we recap quickly the network architecture of option 3x and the mobility overview, what kind of mobility types we have it in non-standalone. Then we'll move into how to check the ENDC or user UE capability message to confirm whether this particular user is supporting, for example, inter or intra-frequency handovers for non-standalone. Then we'll go through the call flow using traces. Then I will be ending by the most common handover failures and related parameters, which is like very common, and I think you will be already aware of it. So let's move forward. So actually, if you remember, this figure already presented in the accessibility slides. This is just like recalling for option 3x, but main takeaway here from this slide, which I would like again to recap it, this kind of distribution of the cells. As you can see here in the left, this is a master node, or this is a 4G, which is the anchoring layer. And we have here the 5G, which is the GNB, secondary GNB, and this is the master node. And here is the UE, and here is we have the EBC, which can be serving gateway and MME, both combined. So we have 4 cells, as you can see here. 2 cells, cell 1 and 3 is for 4G, and cell 2 and cell 4 is for 5G. Just keep it in your mind always. Cell 1, this is a primary, we call it the primary cell, as you can see here. This is a primary cell. And cell 2 for secondary node, this is the primary secondary cell. So usually in most of the networks, you'll find you have multiple carriers maybe in 4G and only one carrier, not most of them, but depend, and one carriers, for example, in the 5G. So in case of carrier aggregation, you will have this cell 3 and cell 4, and this is always called as a secondary cell. So whenever, for example, you are looking in the traces and you're trying to find the configuration for the primary cell of the serving SgNB, this would be always called SP cell, secondary primary cell. So just keep this kind of definition or concept, especially for the cells, into your mind, because this will be very important. So regardless the handover types, we'll cover the next slides in details. So moving forward now, as you can see here in the left figure here, this is just highlighting what kinds of mobility we have it in non-standalone currently. Actually, the most common or most one that initially in any network in the initial phase for any network for non-standalone, as you can see, you have 3 types here. The one which the most common one is just the handovers. We don't have idle mode. We don't have idle mode because still our anchoring in 4G, so the idle mode mobility will be through the 4G. But if you're speaking about 5G non-standalone, we have the SgNB cell change or handover, the secondary primary cell, which is related mainly to the 5G node, and this can be Intra-eNB or Inter-eNB, and also can be intra-frequency or inter-frequency, depending on how many frequencies we have in the current 5G. So this is one of the most common types which we are going to explore today in details. So this is using usually event A3 or O5, as mentioned. A3 and A5, A3 usually for inter-frequency handover, and A5 usually for inter-frequency handover. And the second type, we can call it mobility as well, is secondary cell change. This is in case if you have multiple carriers or 3 carriers, for example, and you have carrier aggregation and 5G, and there is a change of the secondary cell, which we highlighted as a concept in the previous slide. So in this case, A6 trigger can be used, and this is usually actually not only for the interfrequency. This is usually used for intrafrequency when you change it, from example, from one site to another, and you would like to change your secondary cell, or even within the same sites, intra-eNB, if you have one cell secondary cell is better than yours, so this will be changing using this event A6. Then the last one, which is actually whenever you start having mixed network deployment between non-standalone and standalone. In this case, there is a redirection or handover can be enabled from 5G non-standalone to SA to standalone. This is for the 5G standalone capable devices. Who's coming non-standalone, he can move back through redirection or even handover, and this is using B1 event. So these two will be explored in different sessions, like one related to the carrier aggregation feature in general, and the other one whenever we go to the standalone. We'll be covering this one actually in more detail. So today we'll be covering that part which is related to the SgNB change or secondary primary cell change in general. So if you look into the figure on the right, this is the master nodes which is related to 4G, the first one in the left and one on the right. This is two different sites. And we have two sites for 5G as well, which is called secondary GNOB 1 and secondary GNOB 2. So initially, once the user move from left to right, first thing he will do, he will just add the secondary cell of this part. Once he move into the coverage of this particular cell, he will just be adding the secondary GNOB. Then in between here, he might do some, like for example, assuming that this is anchoring already coming in this master node, he might change from this cell, for example, to this cell. So this will be like a secondary cell change. This is it's called usually SgNB modification. Like whenever the GNB having interfrequency handover, it's required to modify the configuration or even the cell through sending something called SgNB modification. And this will be explored in the signaling part. So this will be the scenario, for example, assuming this master NLB, and you have cell A from this particular site, and the user moving from here to cell B, for example. So in this case, the SgNB modification request will be sent from the SgNB to the master node B, asking him that I would like to change from cell A to cell B, my configuration from cell A to cell B. And this is also can be a same concept like we are going to address now for the even Inter-SgNB, not only Intra-SgNB handover. So and here, okay, moving forward now, master NLB, this is the same concept. Actually, the important point I would like to address that we have two types of handovers in general in 5G, which is intra or inter-SgNB and classified into intra and inter-frequency. But still, there is another factors which can be triggered the handovers, which you need also to be aware of it. For example, if you have anchoring change, we have one cell changed in the master NLB from cell A to cell B, or there is a handover in general within the 4G itself. So this can trigger handover. So just one important point, this means if you have, for example, some issues on mobility of the 4G standalone network, will be impacting the 5G, because every time you're doing 4G handover, you would like to also change or release or add your 5G leg as well. So that's why I'm highlighting here master NLB handover. For example, I have here assuming that I'm moving from, for example, master NLB 1 cell A to cell B. So in this case, I might do a change, but in all cases, I need to release and add it again, or this one need to request it to add the secondary node. So in this case, assume that they are still within the same PSCell change, no change, but sometimes you need to change it if you move to another cell as well. But in general, this will be disturbing the 5G, because still once you move from here to there, this will be releasing and adding again the new secondary cell. And also this will be quickly explored today. So this is also one of the things that can trigger, which is usually called MN initiated, which means the handover will be initiated by the master node. Then here, this is one of the most common as well. Now you start moving into the coverage between the red one and the blue one, which is SgNB and SgNB 1 and 2. So here, this is now Inter-SgNB handover. And this is also required as secondary cell change. And this is, for example, assuming here as this one, you are in this side, and you're moving now from cell A of this particular cell to cell B, for example, from this particular side. So in this case, this will trigger something called SgNB handover. And again, this is master NLB handover. This is in case you're completely changing the side. And once you move out of the 5G coverage, we'll be releasing the carrier. So this is just a quick recap or overview. That just the key or the summary of this slide, that yes, the handover will be mainly types of intra and Inter-eNB of the 5G, but still it can be triggered as well through the 4G whenever the 4G having a handover. So this means that you would like you have to take care of the strategy for both 4G and 5G, because then this is very important for like keeping the 5G or increasing the 5G traffic. So let's move to the signaling details. So before moving to the UE capability, I would like to the 5G code flow. I would like first to take you for this one point, which is usually being supported. But in case if you would like to check the UE capability, we need to go into this message, which is called UNR capability NR check. And under that, you would like to search for this measurement and mobility parameters. And here you'll find one parameter called, which is 3GBP defined by 3GBP, Intra and Inter-F measurement and report. This is just indicating whether the user is supporting both intra and inter-frequency measurement or not. So this is, if it's not supported, for example, this means you might have no handover being triggered by this particular user in case of measurement phase. So this is just for your information, and here is the reference for that part. So now let's move to the call end-to-end call flow and see what we have. Okay, so initially I would like first to start with this part, which is related to primary secondary cell change. And here I'm highlighting for Inter-SgNB or SgNB whenever you're moving for, have two different sites for the 5G, and I would like to highlight. So first, let me quickly explain this one, then we'll open message by message to see what we have within this message, and like how can we do the troubleshooting for the handover whenever we are opening our traces. So as you can see in this figure here, initially the ENDC or the SgNB addition is being completed here, and within this completion of the ENDC setup or SgNB addition, there is some configuration related to the handover in general being delivered in our RSU configuration message related to A3 and A5 events, which is intra or interfrequency, depending on your network for sure. If you don't have interfrequency, so it will be only A3. So this configuration already delivered within the RSU configuration, which was being used during the configuration of the SS primary cell during the SgNB addition. So once the user receives this kind of configuration for interfrequency, he will keep measuring. So in case, for example, already the event being triggered, achieved for the threshold which is being sent within this kind of message, and they will show it to you after maybe we finish the high level introduction. Then the user will be sending measurement report, like asking the master node that, okay, I achieved the threshold, for example, threshold, so I would like now to do an handover. So the master node will forward to the secondary node through this exact same information. Whatever here, you'll find it under the RSU transfer as well, which is including a measurement report information to be from secondary node to also to the serving SgNB, and this information including the coverage RSU, and once it's and BCI as well, primary cell identity and physical cell identity. So once it's being received by the 5G node, the 5G node will evaluate this information. And if it's found that this cell is already, for example, in this particular example, it's found that this cell is not under this, it's not configured, it's not part of the cells which is under this particular node. So it will forward this message, which is called secondary SgNB change required, to the master node, telling him that this PCI is not under mine, so please check where you can find this, and it will forward this kind of information again to the master node. Once it's being here, the serving the 4G node will evaluate and check whether they have this in their, for example, configuration, neighbor configuration. So if it's found, yes, it's another neighbors. So in this case, it will do an addition exactly same as what we have explained in the previous session, which is Accessibility session. So it will send this kind of information, the PCI information for this target node, asking him to add it. And here the target node will evaluate now this kind of information, and it will respond with SgNB addition request acknowledgement. And this one will include all the information regarding the SSP and also BCI and all the information about this node which is want to be added for this particular users. Just one quick thing that we'll also highlight in troubleshooting method. So assuming here now there is a missing neighbors between this secondary master node, serving master node, and this target secondary node or SgNB. So in this case, yes, there will be an handover attempt at point A, which is at SgNB change required. But if there is a missing neighbor or X2 definition, for example, issue between this one and this one, in this case, the handover will fail, right? It cannot complete, and it cannot send this kind of SgNB addition request. And it cannot find if missing neighbor. If X2 also will be the same issue. So this is also one of the things that might make handover issues or problems, that missing neighbors between especially for the Inter-SgNB handover. So in this case, yes, you need to take care that all the neighbors is being defined from 4G to your neighbor side. So here the information will be forward, and here this one including exactly the same information. This usually contains all the related configuration, RATch parameters, timers, also the SSP frequency of this part, and also the PCI and everything. So it will be added here. So once being completed, the user will be responding with RSU configuration complete. And here also will be confirmation from the master node to the serving one that okay, SgNB change already done, completed. So this will be counted as successful handover at this particular point. Then also this will be responding again, the master node to the target SgNB that okay, SgNB configuration completed. Then the user will initiate RATch process. And once the write process is being completed, now we'll be moving to this particular part that you find that the old serving 5G node is being forwarding something called SN status transfer. What is this SN status transfer refer to? So in general, SN status transfer, if you look into that part here, you find that here this message is sent from the source 5G, for example, network to the target NG-RAN, supposed to be sent from this one to this one, to transfer this kind of information, which is related to uplink, downlink, BTCP, SN, and something called HFN stats during handover or dual connectivity. So here in this case, I will explain both what it means by both of them. So here, if you find this message, it's initially following from serving 5G to the master node, then exact same information will be forwarded from this 4G node to the target 5G node. And actually what it means by both information, just for your knowledge. BTCP SN, this is referred, like it stands for, as you know, BTCP packet data convergence protocol, and SN referred to sequence number actually. So this is like, it's BTCP SN is a sequence number used in 5G BTCP layer, and actually it's used to sequence and resample the packets. And this is like, for example, to ensure that they are received and processed in the correct order, and to avoid any packet loss during the transmission in general. So just like this kind of message is to align what is the last received sequence number, for example, of the packet. So to be able to know, like, and to be able to order or to reassemble the packets in a correct manner. This is the first part. The component related to something called HFN, and this actually it stands for hyperframe number, hyperframe number, and this is actually in general to represent a high-level frame number that's used to synchronize and coordinate various aspects of radio interface in general, like for example radio interface, including for example the scheduling or the handovers and timing as well. So in a nutshell, it helps to manage the overall timing and synchronization of the radio interfaces within the network. So this is kind of information will be delivered all the time during the handover, and you can see that even in the 4G network. So this, once it's being completed now, you will find that the serving gateway is still forwarding the data, towards the serving the old SgNB, even though the handover is being completed. So still the path is going from this serving gateway, as you can see in the top right here, to this source SgNB, and the transfer is still going through the X2 if you are speaking about the user plane now. So in this case, yes, the data forwarding should be changed, right? So still you'll find that the forwarding is being here, and SgNB is forwarding this data to the target SgNB, just to inform it that there's still data is ingoing from the serving gateway. So in this case, the source node B, the source master node or master node in general, need now to change the path from here to be to this one. So it will send this ERAB modification indication, which contains new IPs of this target SgNB, asking the MME to change the path of the control plane and asking the serving gateway to change the path of the user plane. So once this being done, the MME will notify the serving gateway. This is bearer modification. Would like to change the bearer from this serving to the new target one, in order to send this kind of data forwarding to be done directly from serving gateway to the target one. So once it's being received, this will send end marker packet to the master node and serving node SgNB, old serving GNB. So it will tell him, okay, now I'm not going to forward any data anymore, and it will send a confirmation. So once this being done, if you look into the top right here, now the path will be created. So now the data will be transferred, and once this being received, now the SgNB master node will release the connection from the serving gateway from the old one, the old release. Now I would like, it will take some time, but I would like will be more beneficial for you. I will open message by message just to explore how we can do the troubleshooting, and also what kind of information we need to look into, for example, during the handover process. So now let's start first with MR. Actually, we should start with the RS configuration, but I would like to start with this one for one purpose. So let's open the message and see what we have. So for example, now I'm opening this measurement report, and actually I'm opening the RST transfer. It's including the same information, but I'm just opening the RST transfer message, and you can see this is the figure on the right here, and this is all the information which you can find it. You'll find some information about the X2V ABID, but the more important information, if you went bottom down here, for example, you will find the first part here called an RRC. You will find that this is measurement results. There is something called measurement ID2, and this is very, very important. I will explain why. Then you'll find some information about the serving cell. For example, here is selling that serving cell ID 7, and primary or the BCI is 311, then it's giving information about the RSRB, SN, and the RSINR. And actually the information here is 58. And just to calculate the final one, it should be 58 minus 156. So this means the serving cell having a coverage of minus 98 dBm. And same for RSRQ. You just need to divide by 2 and minus 43. So this will be the RSRQ. So in this case, I don't know the handover will be triggered through RSRB or RSRQ or SNR because we didn't look into the RSRQ configuration. I will go for that, but I need you to continue or bear with me for that part. Then you will find again this PCI is being repeated here. You'll find that there is another PCI information with a new coverage. So what it means by that, and this is still for the serving cell. If you look into that, this is saying serving cell ID, and this is the measurement for the serving MO or the serving MO list. So you have two primary cells. This means this site or this serving cell having one primary cell, SP cell, and secondary cell, which used for carrier aggregation, for example, 5G. So this is, for example, for another one, but I don't know this is for which carrier or for whatever. This also can be checked from the previous RSC configuration messages. So this is also presenting a coverage that this is minus 3 dBm. Then if you went down, now we'll find this is one now called measurement result neighbor cells. And this is having a PCI 505, and now it's having a coverage of minus 90 dBm. But I don't know yet, this is for which event. Is it intra-frequency handover, from what is the current SSP, and this kind of information. So in case if you're doing troubleshooting and you don't know exactly this is related for what, the first thing you need to do is to go for this. If you go up here, you'll find something called measurement ID 2. So in this case, you need to take this measurement ID 2 as a copy. Then you'll go to the previous, for example, RSC configuration message and start looking. This is equivalent to which frequency. This is the first point, and equivalent to which event. And this is very, very important for troubleshooting. And also I have a video about that part. You can look into the troubleshooting part, but let me explain quickly how we can do that through looking in the previous RSC configuration message. So now I have opened the RSC message, which was before the UE delivered the measurement report message from here to there. And the user is delivering based on a previous delivered information related to the events and other parameters as well. Now I would like to see this measurement ID, which is being seen within the RSC transfer or the measurement report, which measurement ID 2 is equivalent to which event type. Is it interfrequency, or equivalent to which kind of frequency? For example, or SSP. For example, here, this is the beginning of the message. It's very long. It's having a lot of information. We'll not explore all of it now. So, for example, this is the called RSC configuration message, which is being delivered during the NDC setup. So what you need to do in that case, you just need to take this measurement ID as a copy. Then you go to here and search for this value, measurement ID 2. For example, look into find next. Usually it's at the bottom, very bottom down. You can see it's taking the message down here. Then you will find here there is something called measurement ID to add mode. You have measurement ID 2, it's having equivalent something called measurement object ID 1 and report config ID 2. So in this case, if you take this one, measurement object ID 1, and search for that one, this will give you this one used for which SSP or which band. So let's search for the same measurement object ID 1 and just move up here. So you can see now, this one is taking out measurement ID, the SSP frequency here, and this is the kilohertz, the subframe number, and the periodicity of the, in general, sorry, for the SSP, which is every 20 millisecond, each subframe. Then you'll find that this is related to band, for example, NC78. So now we know that this is NC78. So if the serving NC78, this is confirming that this might be intra-frequency. But this is still not enough. I would like to take you again for the same one and look into the last one, which is will confirm this one related to which actual event directly. So we have this report config 2 now. If you look into that now, here again, just search for it, go up, you'll find, okay, that's good. This one actually, as you can see, report config ID 2 is related to event E3 measurement. So now it's saying that I have E3 offset RSRB with 6, and the hysteresis is 2, time to trigger is 400 millisecond. And this is the most 3 common parameters. And you have another, for example, related to the report quantity. For example, in the measurement report, there is 3 things reported, RSRB and RSRQ, but which one will be taking evaluated by the 5G node to take the handover. So in this case, it's based on RSRB on. In some networks can be also RSRQ, but RSRB is more used for sure. We don't usually use both or RSRQ. We just usually use RSRB only. So this is all the information related for that part. So now we have this is A3, and you have the offset and the hysteresis and time to trigger. So just in case, here you have 6 and 2. This equivalent to if you divide it by 2, because the unit usually is open 5D. So if you divide it by 2 and this one, each one by 2, so at the end you will have 3 dB, and this should be the neighbor should be better than the serving. This one should be better than serving with 3 dB for 640 milliseconds in order to trigger this kind of measurement report. So this is actually how you can map this measurement ID to the equivalent event. So the next one, let's to go through the remaining message and see what we have. So in this case, once you can see, once the this RRC transfer, which is this message, was sent from the 4G to the 5G, serving 5G. So this is cell change required, SgNB, was including this candidate information for this kind of BCI. So the 5G will look into this information and start to check whether it's part of their configuration or not. So if it's found that it's not part of the configuration, it will return back something called SgNB change required, with saying that, okay, this it's not mine. You need to search for this candidate. It's under which node, but it's not mine. So it will say that now we would like to change completely my SgNB because this doesn't include it in my cell. So initially, if you open this message, which is SgNB change required, you'll find that what is the kind of PLMN identity, also GNLB ID, and also the cause, what kind of cause. For example, here this is the cause of SG mobility, and many other information, important information. So for example, here I would like to search for this PCI, see what we have. Just take this one as a search. You'll find that this one usually is asking it to give it as a candidate. See here, for example. In this case, it's returning back almost the same information, telling them, okay, see, this is the candidate cell info list. SSP is this information, and the measurement ID is 505. The BCI is 505, and this is kind of RSRB, RSQ, and so on. And this is actually also delivering other information related to data split, but this is not our context now or our subject now. So it's returning back that I couldn't find this. It's not mine. So please change this SgNB change it to this kind of information. So now what we'll do? The 4G node will look into this PCI in their configuration or neighbors. If it's found that there is a PCI related to another node, it will forward now. It will try to add it as exactly the same, which being explained in Capability. But let's quickly explain as well, or explain this kind of messages. So we're expecting that SgNB will ask the target SgNB to add this kind of PCI and SSP frequency. So let's open the SgNB addition request again and see what we'll have. So now I'm opening this. I open already the SgNB addition request here. This message after the change required being sent to the 4G. Now the 4G is sending to target node asking him I would like to add. So for example here, this is it's required to change the B primary secondary cell or a SP cell. So if you remember in the very beginning, I explained that there is a concept of this naming of the SP cell and this cell and so on. So in this case, you can even search with the BCI or search for the SP cell. SP cell secondary primary cell. So if you look into that part, so it initially this message, which is GNB addition request, it's covering the information about the current serving cell. For example, the current serving cell for the SP cell is this N78, and also the BCI is 311. And 7441 is for the SSP frequency. And also, if you remember, we used to have the same frequency for another band, which was related to the secondary cell, not the for the carrier aggregation. So if you look into this, for example, you'll find something called SSL to add to mod list as well. This is also still for the serving side. This is still for the same side, which is 311 as well, and also the frequency and N41. So in this case, now we'd like to see where we can find this kind of 505. So if you look into something called candidate, so after looking for this candidate, you'll find, for example, candidate cell info list for the master node. Okay, it's saying that this one measurement result to NR, which is exactly the same, which is being here, 74412, and also the physical cell ID, which is 505, and the RSRB and RSRQ. So once this message is being received, actually, which is SgNB addition request here, now this target SgNB will evaluate this kind of information, and it will see whether it can be added or not, and it will evaluate whether it's part of the neighbors, so it's part of their configuration also. Then it will send this SgNB addition request acknowledgement, including which cells it's required to add, even as a primary cell and or even as a secondary cell, which is related to the carrier aggregation. And for sure, this will be based on your current configuration. So now let's open this SgNB addition request acknowledgement and see what we have. So now I have opened the message which is sent from the target SgNB 5G node to 4G, which will be asking them, I would like to add my secondary primary cell information. So it will be sharing, we are expected to find all the information for the secondary primary cell related to this node, to the 4G, and the 4G later will be following exactly the same information which is being included in this message through our serial configuration. So now let's explore this message and see what we have. So I'm expecting to see this one, which is information for the candidate cell info, which is being added as sent before an addition request. And I expect to see this one as a secondary primary cell. So I will just search for SP cell, SP cell. So this is referred to secondary primary cell. So if you look down here, so I'm expected to see exactly the same information which is above here. For example, if I'm moving down, I have here this SP frequency 74412, and also I have this PCI 505. And now I have the frequency band, which is, for example, band 78 and offset point A, which is identifying the beginning of the band. Actually, I have one video in details related to the SSP frequency allocation. This is explaining all the related details about that part, but this is just simply to identify where is this SSP. Okay, the user know where is the SSP location now, but he want to know where is the start of the band, the channel bandwidth. So this is usually frequency. And also giving information about the carrier bandwidths. And even if you move down to start exploring, you'll find information about the BDCP. Also, I have one video about the BDCP part. Then you will find other more information to the RATCH, for example. And if you're moving more and more about the BUCH, BDCH, also patterns and many other information, even timers, if you move down, CSSI, and also the timers. I would like to see you the timers. For example, if you search for T304, find where is the timer as well. For example, here you have the timers as well. Okay, so this is all the information. You find it in this message in case you would like to do any audit or whatever for the network. So this is including, again, as a summary, including the cells, which is 5G cell, which is required to be added to these users. But if you remember in the measurement report, there was two reporting fields related to the secondary primary cell, and also there is something related to S cell, right? Which because there is a carrier aggregation. So we need to know like whether also this is requesting to add additional cell or not. If you remember the naming, if you speak about the carrier aggregation, you need to search for something S cell. In case if it's required to add something related to the carrier aggregation, it should be called S cell to add to mod list. So let's search. So yeah. Okay, now going down here, you'll find something called SL to add to mod list. Now it's requesting, yes, I would like to add this physical cell ID, which is 874, and this is the frequency and frequency band, and this is a SSP. So as you can see now, it's asking to add two actually, one as a primary and one as a carrier aggregation with that part as well. And this actually, there was no measurement, if you remember, there was no measurement included about that part in the RC transfer for the target, target SgNB. So only the one which is being sent, it was 505 for the neighbor. So this means there is a blind configuration in this kind of site. This is like my explanation for that part. So now I'm expecting, the exact same information will be forward from the node to the from the master node 4G to the UE. This will include exact the same information here. Now we'll have this confirmation that I have received this message. Once you have this message now being received, let's take this down, just continue. Again, we'll complete with the remaining process related to the SgNB confirmation, and SgNB confirmation complete here, and we'll start the ranch process. I would like just to quickly explain again for the SNS status transfer, just show you quickly what we have in the message. Then we'll go move forward for the remaining. So as explained before, this is SNS status transfer, just including this information, which is important related to the sequence number of the BCB and the hyperframe number as well, just to align the frame and sequence of the orders of the packets and so on. This is the main information. You can find it here as a quick part. And ending by that part, the era modification indication will include the transport ID and JTB ID as well. I have also explained this one in the session which should be addition. So now this is being done. We'll move now to the simple one, which is related to the Inter-SgNB handover. It will be next slide. As you can see now, the primary secondary cell change, but this time it's Inter-SgNB within the same site. So this is actually it's very easy one. As you can see that initially the measurement reports being sent will cover exactly the same information being explained before, and will have RC transfer. Then we'll have this SgNB modification request required. So let's open this message quickly and see what we have in this message. So before opening these two messages, I would just like to take you into the quick overview about that part on the right. So as you can see, this is just Intra-SgNB handover. That's why it's between the same sites, so it's okay. And assuming this is inter-frequency handover, so in case of inter-frequency, it should have the exact same SSP position. And if in case of inter-frequency handover, right? It should be like the SSP position, even if it's within the same band, assuming the same band, but the SSP position is different. This will trigger inter-frequency handover. So just like quickly recall us or recap for that part, that the handover is mainly controlled by the SSP. So it's not about it's not the same concept of the 4G. Now the SSP the location can be different in the band. So even within the same bandwidth, the same band, you can find a different SSP position between cells. This can cause inter-frequency handover. So now let's open the messages. Let's open the messages for the other things which you have it for this measurement report and this modification required to see what we have. So now I'm opening here on the right. You can see you have here the measurement report being sent. So in this measurement report, if you again explore it, I'm opening the top left here. If you go down here, again, you should find the serving cell and neighbor cell information as well. So here there's a serving cell information, which including PCI 310, and we have Darastar BSNR and Darastar Q. And moving down here, you will find also again repeated for the serving cell 310, which means that you have carry aggregation for this side, this second information for the secondary cell for the serving, which is also that part. Then you will find the measurement result neighbors as well, which is PCI 309. So now, once this being received by the SgNB, serving unit, it will evaluate this kind of information. Then it will request through the SgNB modification required from the 4G node to start adding that part through our serial information message. So we're expecting again, if you search for exactly the same information, for example, we should find this SP cell under the SP cell, which is 309. So for example, if you search for SP cell, you'll find, for example, okay, good. So you find the SP cell configuration. Okay, I would like to add this one, 309, as my SP cell, primary cell, as a 5G leg. So it's asking the 4G node to do that. So again, it will include the information 309, frequency, band, and so on. And again, it will cover all the other information. And in case if it would like to add also a carry aggregation cell, so we need 2 cells for secondary cell chain, secondary cell, add to modulus. This is referring to carry aggregation. So yes, it will be adding also secondary cell with band 40 and, for example, PCI 309. So this is actually also the exact same information. And now our SU configuration will cover exactly the same information as being here, and once it's completed, it will be confirmed, and now there is a random access. But if you look into that scenario, you'll find that there is no path switch, because no path switch change, because this is already Intra-SgNB, so the path still will be going through to the same node actually for that particular case. So this is explaining that part, and this is more easy as well. But one of the important things I would like to highlight to you, SgNB modification required in general can be for many different things. It's not only for a PSCell change, for that case, for example. SgNB modification required can be for any parameters or configuration change within the SgNB. In case there's any change and it's required to inform the user, so it needs to forward. For example, if you have a change in the uplink data split threshold, let's assume that for uplink that split, I have also a video about uplink throughput, and you can look into that part. If, for example, assuming the user now would like to fall back to the 5G network or stop the splitting for the uplink, so this kind of information should be delivered from SgNB to the master node B to request the user, for example, to stop doing uplink splitting, as an example. So in this case, SgNB modification required will be sent, which is covering the new information. For example, this feature for the DRX, for example, if you haven't changed in DRX, also be sent from here to there. Also for the uplink waveform feature as well. This can be if there is any change, the user is moving from, for example, from 1 layer to 2 layers or whatever for this uplink feature for the CB of DMA and so on. So this will be also sent from the information sent through SgNB modification required. What I won't say that SgNB modification required, yes, it's during the Inter-SgNB handover, but also it can be used for other things, as mentioned here. For example, gap request change or any other configuration change within the site, and on top also SgNB primary secondary cell change. And also sometimes you'll find modification requests being sent from the serving SgNB to the 4G, also asking about some change. For example, if this case, let's assume that you have interfrequency measurement is being going. So sometimes here there will be a step before that RSC configuration. It's not mandatory, but sometimes you find it that this would be providing, for example, something related to security or the gap information to align the gap information between the source and the target and the 4G and 5G node. So this also will be sending before that step being completed, it will sending SgNB modification request, which is including the information which should require to be aligned between the 4G node and 5G node. So there's also this extra information you need to consider as well whenever you check, because you might find some extra step, and some cases, as you mentioned, you will not find this RRC transfer because SgNB modification required for something else. And modification in general means that you are changing something within the node, for example, configuration or a handover, as this case. So now let's move to the next part, which is related to the just quickly. I will not go through the details for that part, but just, for example, explaining that whenever you have handover in the 4G node, as you can see here, for example, there was a handover from this node. This is Inter-eNB Handover from the source node to the target node. As you can see, handover requests being sent from here to there. And once it's being sent, now there'll be a change for the secondary cell change. So this one will be sending again additional requests from the beginning. So again, the change of the secondary cell can be also triggered by the handover from the 4G node. This is as well. Like, this is just signaling from reference. It's just rated majority is 4G, and this is just main takeaway from here, that 4G also frequent handovers can impact the 5G performance for non-standalone. So you have to take care of that part as well. So yeah, this is for for example, ENB handover, what's being triggered. Also, this will be requesting additional change for adding the new information for the new target SgNB, and also will release the old one. And exactly the same for the Inter-eNB handover, but this can be done without a cell change. For example, there is an Inter-eNB handover being done, but they are sharing the same secondary cell change. So in this case, the target master node will request from the serving gateway that I would like to add you, and once it's being added, the old serving will release this kind of information from the serving GNB. So this also another information, and this is having both switch change at the end for that part as well, because this inter. Then moving forward now, this is related to the parameters. Actually, in general, the parameters, as you can see here, I just give the list is the most common parameters, but you have even more parameters than that. But just to explain quickly, because sometimes you see this figure and you might get confused. So for example, this here is speaking about wide-rated parameters. You have A3, A2, and A5. I'm just listing things, the most common interfrequency and interfrequency handover. So assuming that you have A3, this is a formula for inter condition. You have many things like OCN, stresses, OFS. For example, this is related to, you have CIO, for example, cell individual offset and frequency offset. This also can be added, but usually we tune this tree, and others maybe, for example, CIO can be done through some features. So for example, here you like, this is the most three common parameters. If you look into this figure, this is just explaining when the handover will be, or when the measurement report will be sending from the UE to the ENB. So for example, now assuming that this blue line is for the neighbor cell, and the red one is for the serving cell. So you can see it till here, this is for the serving cell. You have an offset. So the neighbor should be better than the serving cell in order to trigger the handover, right? In order the UE to send measurement. But for how long, or what's the offset? So now it's adding this. You have E3 offset, you can see. So this is the neighbor cell. As you can see, this is the serving. So this is the neighbor. It's adding an offset to this hysteresis first. Here, this hysteresis mean, then the offset, for example. So the neighbor should be better than the serving with offset plus hysteresis, right? Neighbor should be better than the serving with offset plus hysteresis. So here this being achieved, both of them. So here, this is the first point that the user will start the time to trigger, because already the neighbor is better than the serving with offset and hysteresis. A3 offset and the hysteresis. So it will start time to trigger. Assume that time to trigger is 640 milliseconds. So if the neighbor keep consistent better than the serving with the hysteresis and offset for 640 milliseconds, in this case, the user will start reporting the A3 report to the ENB, and the ENB will transfer this information to GNB, and it will continue the same as that, what we have explained before. And just to highlight, this is also exactly the same for 4G as well. So exactly the same information. And there is some details about that part in 5G and R in Bullet's box. And also, I think it's already covered in many other information. Last part that I'd like to end with is most common failures in it's not actually frequently happens, but this is like in general, I try to collect whatever cases I am aware or I have seen before. So for example, you have, as I highlighted before, you have this missing X2 definition or missing neighbors. Usually the missing neighbors are not causing handover failures. And speaking about the 4G network, but in 5G network, it can cause even X2 or missing neighbors can cause handover failure. Why? If you remember this figure, which we explained in the beginning of this session. For example, here in this case, in the Inter-SgNB handover, the UE reported the AI MR report, send it from UE to measurement report. Then this will be transferred to serving SgNB. Then the serving SgNB send SgNB change required because this was not part. BCI is not. It's not part of this kind of cell. So here in this stage, the 4G node received this information of this, which including the BCI for this new target. So if the neighbor is not defined for this 4G node to this one, in this case, the handover will not be successful. Handover attempt already recounted. So in this case, there will be no response from the 4G network because this is already not defined. So it cannot be. So this means if the missing neighbors are there between the 4G and this for the Inter-SgNB handover, in this case, this will cause a failures, handover failure. And also missing X2 definition, assuming there is no X2 defined between this one and this one, the same will happen for any message exchange between both of them. So this is also why it's happening. Also for sure, if you have PCI conflict, this is also something normal. And sometimes is the target node having admission control, for example, having high load in users or license limitation or whatever, depend on each vendor specification. And also there is a transmission issues impacting, for example, the X2 link. And sometimes, honestly speaking, I didn't see it that much, but sometimes there is some rare cases where there is UE capabilities during the handover, which is refusing the target cell will be refusing the handover, and this is sometimes you can optimize that to different. The vendor have different mechanism of that part, and this is also one of the rare cases which you can see. This is the kind of a race condition, like if there is already ongoing handover and there was a SgNB modification being sent from the 5G node to the 4G node. In this case, the 4G will reject it, will send SgNB 4G will rejected by SgNB modification refuse, and it will contain this kind of compatible with receiver state, and that's indicating that there is already ongoing procedures for handover in the 4G, which is called race condition or signal interference. That's why it's preventing the handovers. And this is also mentioned the cause of that, mentioning the 3GPP here as mentioned in the source. So that's it for today's session. I hope if you like the session to spread the knowledge and share it with your friends and to like and comment. And please share your comments and feedback. Your feedback is really needed to keep optimizing whatever content I'm trying to present. And also, I would like to request you to send whatever contents you would like to add for the series of the 5G non-standalone channel to make sure that we have a complete understanding. Well, thank you and see you in the next video.